This is the geometric relations portion of this activity. Notice I'm switched over to my geometric relations tab down here. We were just on the smart dimensioning tab. So up at the top, the directions say that we have 12 different exercises. And in order to select multiple things at once, you need to hold in the shift key while selecting them. So we see here that we have a single line and it's blue, and then a circle that's black. So the difference in color means this is underdefined. I can still move it around, I can resize it, I can reshape it. This, however, is currently locked. It's stuck in place. So it's actually locked with this little symbol. This little green symbol of an anchor is actually the fixed symbol. This is a geometric relation that we'll never really use, and that's because it lies to us. It takes away the degrees of freedom. It takes away the ability to dimension it and move the shape. So that's not something we necessarily want to do. So in this activity, I have several things that are locked, and that's because I had to do that so that you can actually learn the different relations with the other things. So this first one says that we need to make the bottom endpoint of the line on the left merge with the center of the circle. So if I click this bottom endpoint, hold in Shift and click the center here, notice SolidWorks puts up a whole bunch of relations on the left side. It tries to think through what relationships are possible. And in this case, the merge is. So if you are taking notes, notice the symbol here has a single line and another single line coming together at one small dot. So if I merge these two, now it's stuck. It can't move. So you watch. I'm going to try to resize this. I can resize it, but look where the other endpoint always is. Always stuck. So even if I try to move it, I can't. It's stuck in place. It's merged with the center of this circle. Moving on to number 2. It says make the bottom endpoint of the line on the right coincident with the outside of the circle. So if I click the bottom endpoint, hold in Shift, and click the circle, select coincident. So now it took the bottom dot and connected it to this circle. So once again, if you're taking notes, find that symbol, write yourself a definition. But you can see that if I try to move this left or right, always is going to be stuck on that circle now. Okay, it's coincident to it, stuck. Number 3, this says make the circles concentric with one another. Co meaning to share and centric meaning center. So if I select all 3 of these circles and select concentric, notice the symbol. If I select concentric, it's going to line up the center points of all 3 of these circles. So they're sharing the same center. Now, number 4 is one of those activities, or one of those relations rather, that we barely ever use. Maybe there's a reason for it. Honestly, I don't know why we would ever use this, and you're going to see why. This says make the circles co-radial to one another. Co meaning to share, and radial meaning having the same radius. So they're going to turn into the same size. But watch what happens. This circle is currently stuck here or fixed in place. So I can click on this circle, hold in Shift, and click the other one. And when I select co-radial, notice the symbol, it's going to take that small circle, jump it on top of this one, line up the center points, and then resize it to be the same size as the other one. But here's the problem. It's gone. You can't use it. You can't even move it. It's stuck. So I don't really use this relation ever, and I don't recommend you do either. But I do want you to recognize the difference between co-radial and concentric. Okay. Now we'll pick up the pace here a little bit. Number 5 says make the lines parallel. So if I hold in Shift and select these lines, notice one of them is already locked in place. And parallel means that they're never going to intersect. So when I select that, they line up to be at the same angle as this line, and it'll never intersect. Number 6, however, says make the lines perpendicular to one another. Perpendicular means the lines are going to intersect at 90 degrees. So if I select this line, hold in Shift, select the other one, find the perpendicular symbol, which is an upside down T, and when I select that, it intersects at a perfect 90-degree corner. Number 7 is very easy. It says make the lines horizontal. So you can see if I just click on a line and hit horizontal, it turns it sideways. Okay. Number 8, this one says make the lines vertical. So same thing, but opposite. They're just going up and down now. So you'll use both of those relations a lot to line things up with one another. Number 9, make the single line collinear with the bottom of the rectangular object. So co meaning to share, and linear meaning line. So they're going to share the same line. So if I select the bottom of this, hold in Shift, click my other line, and then find that collinear symbol. Again, if you're taking notes, find it on your paper. Collinear means to share the same line. So you can see, even if I resize this single line, it will always follow that same angle. Number 10. This is a new term for a lot of high school students. If you've taken geometry or trigonometry or even calculus, maybe you've already heard of it, but most students that have taken algebra, you don't really work with this term. It says make the line tangent to the arc. So we have an arc that's stuck or fixed in place. And if I click that, hold in Shift, and then select my line, notice the tangent symbol shows a curved surface or a curved object, which in this case is a circle, touching a line. So it's actually touching it at one single point at all times. This is much like taking a bowling ball and rolling it across the floor. Even though that ball is moving, it's still touching the floor at one single spot at all times. So the bowling ball would be tangent to the floor. You can do this for multiple things. So the second part of this says make the circle tangent to the angled lines. So if I select this circle, click on that line, make it tangent. Click off, then click the circle, hold in Shift, click the bottom line, and hit tangent. Notice it shoves it into that corner and sticks it in place. So it's tangent to both of these. So if we were to right click on this dimension and hit delete, if we try to resize this dimension, it's still tangent. Now you don't have to do this, but I just wanted to show you that. Then an easier one, number 11, this says make the triangle an equilateral triangle by using the equal constraint. Okay, so one side is already dimensioned. An equilateral means that all sides are going to be equal. So if I select these 3 lines, there is an option over here in the relations that says equal. And if I do that, it changes all of these sides, so meaning this one and this one, to be the same size as this. And since this is already dimensioned, they are both 1 inch. Now, if I was to change this 1 inch to say 2, it's automatically going to change the other sides to 2. So they are always equal to one another. Number 12, this is kind of combining a couple different ideas. This says make the circles all the same size and then line up their centers. Do this all with constraint tools, not the dimension tool. So if you're following this video, I would recommend to pause the video and try to do this on your own, and then play the video again and see how I do it. So I would do that now. So if you did follow with me there, or you tried it, you might have added some extra relations and maybe it's not working for you. Maybe your screen went yellow, you got some warnings. Just watch here what you should have done. So to make them all the same size, you would be selecting each circle. Notice I'm not clicking its center point, I'm clicking the outside of the circle, and I'm making them set to equal because this one is dimensioned. So now they all resized. Then it says line up their centers. So if I click this center and this center, I can make them vertical. This center and this center, make them horizontal. make these two vertical, and then these two horizontal. So all of their centers are now lined up, and they're all the same size. And that's it.